Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up rotational motion lecture number 2 in the physics section 1, useful for JEE Advanced, JEE Mains and NEET Physics. I had released one lecture on rotational motion 1 in which I have described a small portion of the introduction and I had solved a problem. To have a glimpse of the rotational motion, how it works in the physical sense. Now, in this lecture, I will be taking up the classes regarding the rotational motion from the beginning to the advanced level. In this lecture, I will be talking about derivation of the velocity vector in rotational motion. This is the velocity vector in the rotational motion. R is the radius, or we can even say magnitude of the vector R. dr by dt is the differentiation of vector R with respect to time, and r cap is the unit vector in the direction of the vector R, and d theta by dt, it is linear velocity. dr by dt is linear velocity and d theta by dt is angular velocity. I want to show you an equation in the differential form for the total velocity vector, how it is connected with linear velocity and also angular velocity. The equation is V bar is equal to dr by dt r cap plus r into d theta by dt theta cap. You remember, in the linear or rectilinear motion, one dimensional linear motion, there is only one variable that is changing with respect to time, that is x direction, linear motion. In that, dx by dt is velocity, x is the displacement, and dx square by dt square is equal to acceleration. But here in the rotational motion, both linear parameters vary with time and also angle also changes with time. Hence, we will get angular velocity and also linear velocity. We will derive this equation, and first we start with what is physics and what are the laws of motion and how those laws of motion we will be evaluating for the rotational motion. We will dwell into the lecture. This is a very important lecture. Don't miss out even a single sentence. Every sentence is very important to understand the concepts. In physics, there are two types of situations in mechanics. This rigid body rotational motion is a part of mechanics. One situation is particle mechanics. Particle mechanics, what is the meaning of it? Everything is treated as a particle, and a particle by meaning, by definition in physics, a particle has mass but does not have linear dimension. How big the mass may be, 2 kg mass, 3 kg mass, 2 grams mass, 2 milligram mass. If you treat it as a particle, it does not have any linear dimensions. That means diameter, length, breadth, height, linear dimensions are negligible, or they are not there, or they are not considered in a particle mechanics. Usually, till the rotational mechanics is studied, we study only the particle mechanics for Newton's laws of motion, for also projectile motion, for everything till now, till rotational or rigid body motion, we studied the particle motion. That means sometimes in front of universe, space, universe, galaxy, we have taken even Earth as a particle and resolved. So particles size does not matter when you are doing the particle mechanics, when you are going to an approach like particle mechanics. For example, a pendulum is there. How you have got T is equal to 2 square root of L by G? We have only considered the pendulum as a particle. But pendulum is of bigger size and pendulum mass and dimensions are also taken into consideration. The approach is different. This is not about the big size or small size, it is about what is the approach we have adopted. That approach decides about the particle mechanics. The type of the mechanics and their rules are applied. One is particle mechanics. Second is rigid body mechanics. I am only talking about the classical mechanics. Here I am not taking the quantum mechanics. I am not talking about the quantum mechanics here. I am only talking about the classical mechanics, physical mechanics rather, which is physically available in front of us. A ball is available, a ladder is available, an inclined plane is available, and a desk is available, a book is available, a pen is available, a rotating body is available in front of you, which is available in physical sense. That's what I am talking now. Earth is available in front of us. In rigid body mechanics, a rigid body is a collection of particles. That means it is not a single particle mechanics. Here, the size of the rigid body matters. The mass of the rigid body matters. It is a rigid body is a rigid body has particles spaced very closely to each other. So that the particles displacement among them does not take place under normal conditions of external forces. Except the forces that affect the molecular structure under normal conditions, a rigid body is taken means that rigid body particles are fixed in the space. They do not change. They are fixed like a cricket ball. Cricket ball will not that easily de-shape itself. The molecules will that easily will not move here and there. The particles, they stick together in the shape of the ball until unless it is subjected to a very high impact where the shape of the cricket ball itself is spoiled. That is one of the best examples. If you are writing on a table is a rigid body, and that rigid body molecules will not change often, or particles inside will not change, that remain glued together, that remain closely cohesived together, so that the external force like putting a hand on it, writing on a notebook is not going to affect the table's molecules until and unless it is broken with a great force. Hence, the study of a rigid body, third point is the study of mechanics in rigid body is different from the study of single particle. That means this study differs. The laws of motion may be same, I will come to that, but the application of laws of motion will not be same to a particle and to a rigid body. Now, this is about the type of the mechanics. Two types are there. One is particle mechanics. Till since your 8th class, 9th class, 10th class, you have studied particle mechanics, and Newton's laws of motion, you have studied particle mechanics. And now you have come across the syllabus of rigid body mechanics. Rigid body mechanics is different from the particle mechanics. That much you keep in mind as of now. Now, in a rigid body, what happens is that particles are there. Every particle will have a position vector. If the particle, if I feel that it is a point, a rigid body is like this. Please understand this concept, very, very important. Rigid body is like this. There are particles. And these particles have certain coordinates. And this particle 1, it has coordinates x1, y1. It is a particle in the rigid body only. It is particle 2, x2, y2. I am only giving example. There will be lakhs of particles, crores of particles in a rigid body on the size and shape. x3, y3. It is fourth particle, x4, y4. This is fifth particle, x5, y5. And whenever anything, its position to be defined in a space, what is required? A reference is required. In physics, without a reference, any quantity is immaterial. It does not have any meaning. If I say, my pencil weighs 30 grams means, what is that 30 grams? A gram is defined, or a kilogram in SI units is defined somewhere in a laboratory. That weighment is there. In respect of that weighment, this is what is what. Means there is a reference. If I say my house is 2 kilometers from my railway station, the 2 kilometers distance is measured on the basis of the reference in SI units that is meter. That is kept in the laboratory somewhere. And for every country, there will be National Physical Laboratory for calibrations. In National Physical Laboratory, the weight, length and time, the scales are kept there. On the basis of that, calibrations are done. That is the process. At international level, they are there at international level. National level, National Physical Laboratories are there. That means with reference to something, I am defining my physical quantity. Few years back or few decades back, people were measuring in mil. Today, in SI units, we are measuring in kilometer. The measurement aspect may change, but some reference is always kept somewhere with reference to that this is so and so. Now, these things reference I have explained in vectors classes. Please refer to my old classes on vectors. Now let me say, this particular rigid body has 5 particles. It is only an example. It is not possible for a rigid body to have only 5 particles. I am only taking 5 particles for our reference, for our understanding. And reference is origin, universal origin. Without reference, there is no meaning, either distance or angle or anything. First particle is this way with reference to origin. Second particle is this way with reference to origin. Third particle is this way. Please understand this concept carefully. Listen to me carefully. If you want, you can write the notes also along with me. These 5 are there. Now, one important aspect in the physics which everybody has to know, that is degrees of freedom. If this particle instead of 2 coordinates, if it has 3 coordinates, if it is in space, let me say, I have another axis also as z. This is x, this is y, and z is also there, means I will add x1, y1, z1, x2, y2, z2, x3, y3, z3. Why I have not written previously? The reason is that I want to emphasize upon. Now you tell me, what is the degree of freedom for individual particle? This is z, this is x, this is y. For a particle z, not z, let me say some p, x, y, z, the particle coordinates. This particle can choose anywhere. Space is there. It is a 3-dimensional space. That means a particle can have any coordinate. In y-axis, plus infinity to minus infinity, the particle can exist. In x-axis, plus infinity to minus infinity, the particle can exist. This particle can be here, this particle can be here, this particle can be here, this particle can be here. There is no restriction. The particle can be here. That means a particle has the freedom in a 3-dimensional space of choosing its own coordinate until and unless you have not put the position condition there. That means a free particle has 3 degrees of freedom as far as its coordinates are concerned, its point is concerned. position is concerned. A particle has 3 degrees of freedom. No, it's not yet completed that degrees of freedom. It's 3 degrees of freedom for only particle. It is your freedom to choose to put the particle anywhere. I have not taken care of the position vector yet. Now, if there are n particles in a rigid body, how many degrees of freedom? It will have 3n degrees of freedom. But a rigid body, please remember this, it is very important concept. A rigid body position can be fixed by choosing 3 particles. For example, I have a rigid body here. If I have only one particle position chosen, then the rigid body can rotate about that. Yes, it can move. It can rotate this way. It can rotate this way. It may not be able to move horizontally because movement is restricted. If I take a rigid body, a small cardboard, and put a nail on it, that is in one way I am fixing it. This is the point I fixed through a nail. But I can rotate it. I can rotate the cardboard, that is rigid body. Are you able to follow me? This is very important. And if I fix another point here, this is point 1, and if I put another point here, another nail here, second nail on the cardboard, still I will be able to move it. Still I will be able to move it, and a rigid body can be fixed only when 3 points are fixed. I will put the third nail separately of the position of first and second nails. Then that rigid body cannot be moved. That means it is very important. 3 points are position vectors can fix a rigid body position. A rigid body position. That means when I can choose 3 crucial particles and fix them, I will nail, then what happens? That rigid body will not move. I have restricted or constrained the movement of that rigid body. Then, how many particles are there? 3 particles are required for fixing the rigid body. For fixing a rigid body, 3 particles are required. That means for choosing the 3 particles, coordinates, what is the degree of freedom I have? 3 into 3. Degree of freedom is equal to 9. Please understand this. This is very important. Once you get this concept, that means I fixed the rigid body on one corner of the wall, another corner of the wall, center of the wall, cardboard, and other side of the wall. This is all I am doing because I have the freedom to choose the coordinates. I have 3 particles coordinates to be chosen. Then I have 3 into 3. 3 particles are there and each particle has 3 coordinates. Total I have 9 coordinates and my degree of freedom choosing the coordinate here 9. There are, what are the 9? x1, y1, z1, x2, y2, z2. Please understand this. x3, y3, z3. How many are there? 9 coordinates I am at liberty to choose. 9 degrees of freedom. Now, in the first instance, I have fixed one point. That means x1, y1, z1 I have chosen. Then in the second instance, I will not have freedom to choose x2. I can only choose y2 and z2. In the third instance, I will not have freedom to choose x3 and y3. I will have only z3. Therefore, net degree of freedom is equal to 6. For a rigid body, the degree of freedom is 6. Now, their degree of freedom is there. We got the degree of the freedom. We understood the concept of the positioning of the coordinates. Now, next comes the another most important. I have spoken about the reference. Why I told these things, you will come to know as we move through the rigid body motion in detail. These are the basics which you should understand. Next is, I have spoken about the references. Now, there will be 2 conditions of references. For example, first condition is, I have chosen my origin as 0, 0, 0. That is, that origin is my school library, let me say. I have chosen that as my origin. School library, I have chosen it as a origin. And I have fixed a point P with reference to that origin. Some P is there. It is at a coordinate of x, y, z with reference to my origin O, that is my school library. In the school itself, there is a hostel and my friend has chosen the origin as his hostel room. It is the origin, hostel room. This is y, this is x, this is z, and this he has chosen as, it's not to scale, please don't worry. And he has chosen a point here P. For him the P will be different. For the magnitude, he has chosen here. This is O. This is, let me say, x dash, this is y dash, this is O dash. When origin shifts, when the origin shifts or the coordinate system shifts from x, y, z axis to x dash, y dash, z dash axis, in a homogeneous space, the coordinate system changes will not change the particle properties. Homogeneous system means homogeneous space. in homogeneous space, a translation of the origin, translation of the vector, please try to understand, translation means movement of the vector from P to, this is P dash, will not change its properties in a homogeneous space. If space is homogeneous, the properties of the particle will not change. If the space is homogeneous, by translational changes in the origin or coordinate system. This is called as translational invariance. That means by translational, that means by changing the coordinates from my origin, from my library to my friend's room, hostel room, the particle properties are not changing, means this is a homogeneous space. In a homogeneous space, when the particle properties are not changing, then this is called as the translational invariance. Why I am telling these things? These are may not be there in your textbooks or anywhere. Why I am telling these things? That these basics are compulsory required for understanding, better understanding of the rotational motion. Because rotational motion involves translation plus rotation also. Translation plus rotation, or both are involved in this rotational motion study of rigid particles, rigid bodies. So that we have to study the translation motion and also rotational motion. Now, this is about the translational invariance. Variance means vary. Vary means change. Invary means doesn't change. What is the translational invariance? In a homogeneous space, when the particle properties do not change by changing of the coordinate system from y z x to y dash x dash z dash with an origin o dash, and initially it was a origin o, then there is a translational invariance in homogeneous space. Now, another example we will take. This is the coordinate system, because understanding of the coordinate system is very important in case of rigid bodies. Please don't neglect it. And drawing this x, y, z axis also is an art. Please learn it. When you draw yourself, you will understand the meaning of it clearly. If you want, you see my video number of times. Draw it yourself. Figures whatever I am drawing. Now, I shifted the angle of the axis. I am not disturbing the orthogonality of the axis. That 90 degrees is perfectly there. This is the angle between x and y is 90, and x and z is 90, and y and z is 90. This I am not disturbing. These are three mutually perpendicular axes in this space. I have taken a point here, P, such that it has the coordinates as P, x, y, z, and I had connected it like this. This is O, 0, 0, 0. This is what? I told you, it is an example. I am just sitting in a boat on a water, and My boat is going smoothly and suddenly there was a wave, boat has tilted. What happens? My viewing angle changes. Origin is not changing. I am same. I am there in the boat only. There is no translational movement. In the previous example, it was from library to friend's hostel room. Here I am sitting there only in the boat in the same seat. Seat number is also not changing. But only boat is tilted because of the wave. Slight tilt by theta. What happens? In the same origin, the axes are tilted. Axes are tilted like this. Please try to understand the meaning of it. Axes are tilted like this. Let the new axis be x dash, y dash and z dash. The angle between the axes is also 90 degrees, but axes are tilted by theta. This is called as rotation in a rigid body. Translation in a rigid body you have understood. Rotation in a rigid body. In a homogeneous space, by tilting of the angle, if the properties of the particle, this is a particle P dash with coordinates as x dash, y dash, z dash, and from the same origin, it's a positional vector. It is with respect to x dash, y dash and z dash. Position of P, new position, P dash. As long as space is isotropic, here it is not called as homogeneous, here it is called as isotropic. Isotropic means looking in all the directions similarly. You are sitting in the boat, even the boat is tilted, the cloud whatever you are seeing in the sky, that's not changing, you are able to see it. That means there is no change in the properties in the space because of the isotropic nature. This is isotropic space. These words are important. Questions may come on these words. Isotropic spaces. In isotropic spaces, there is a rotational invariance. I have already explained you what is invariance. It is rotational invariance. That means when you consider a homogeneous space and an isotropic space, why I told this? Usually for simplicity, in physics problems, we consider space to be homogeneous and isotropic. We don't give attention to those words because we have not dealt their in-depth meaning like this previously. Now, when this space is homogeneous and isotropic, that means this space has translational invariance and this space has rotational invariance. That means tilting of the angle on the axis is not going to make any difference as long as the orthogonality is maintained. That is isotropic invariance or rotational isotropic space, rotational invariance. Shifting of the axis from one point to another point, as long as the space is homogeneous and properties of the particle are not changing, it is called as a translational invariance, that process, and this space is homogeneous. That means what is the ultimate conclusion? Because this conclusion is required in rotational motion, rigid body motion. What are our conclusions? One is, in a homogeneous space, If any word is used like this in your examination, it means there is translational invariance. Invariance means it does not change. It does not vary. It does not change. Variance means change. Invariance means opposite of change. Second, isotropic space means there is rotational invariance. We will be taking up our cases in this space where it is a homogeneous space and also isotropic space. We deal with homogeneous and isotropic space in this rigid body motion. This is a in this sense, we are simplifying the rigid body motion. That means we are telling that there is not translational invariance, there is a translational invariance and there is a rotational invariance. With this condition in mind, what is the major constraint that can define a rigid body? The major constraint that defines a rigid body is the particles are rigid in their places. They will not move. That means because of the motion of the rigid body, when laws of motion are applied, there is a translational invariance. The particles are not moving here and there. There are two particles, let me say. Please draw a diagram here. For everything, it is better to draw a diagram and understand it. Let me say particle P1 and another particle P2. This is X1, Y1, Z1. This is X2, Y2, Z2. Now, from O it is connected this way and from O it is connected this way. Positional vectors are OP1 and OP2. When I taught you vectors, I told vectors are going to be of much use in understanding the physics. Physics is of theory. From theory, problems do come. Let's not jump to the problems directly. Let's understand the theory behind it. And the distance between two particles, P1 and P2, it is fixed. In a rigid body, please try to understand. P1, P2 is fixed. Until and unless the force is such a huge that it breaks the rigid body. Under normal conditions, the distance between two particles is fixed. The displacement between two particles is fixed. P1, P2 is fixed. P1 is X1, Y1, Z1. P2 is X2, Y2, Z2. This let me call it as R12. Let distance between two particles is R12. R12 is equal to P1, P2 vector magnitude, that is fixed. This is constant. Let constant be denoted by C. The same may not be there between P2 and P3. P3 may be here. P2, P3 is fixed. P1, P3 is fixed. R12 I have shown it as an example. It can be Rmn is a constant. This is one of the properties of the rigid body which comes into use as we go on studying the rigid body motion. Now, till now, we have understood the rigid body, what it is, and what will be its variance or invariance in homogeneous space and in an isotropic space, and what type of space we use for studying the rigid body at our level as of now for JEE Advanced, JEE Mains and NEET. This much understanding of the space, rigid body dynamics, rigid body coordinate system is sufficient, and degrees of freedom. Now, when my rigid body is there, and a reference system is there. Their reference system means it's not only origin. Actually, I will tell you. A reference system is a frame. Reference frame. What is this? We say 0 is the origin, Y is the origin, O dash is the origin. What is this actually means? X axis, Y axis, Z axis, and here it is X axis, Y axis, Z axis, and here it is X dash, Y dash, Z dash. Here we will remove this. Extensions are not required for understanding. This is the point O, let us say 0, 0, whatever may be. Let us not call it as 0. 1, 1, 1 can be an origin, no problem. Reference point. I can call it as a reference point instead of RC. Now, this particular coordinate system is called as a frame. This is frame 1. This is frame 2. When a frame is defined like this, and in the frame, it is a homogeneous space is there. Within that this frame is there, homogeneous space and isotropic space. That means there is a translational invariance. Translational invariance plus rotational invariance is there. Here also translational invariance plus rotational invariance are present. Then in frame 1 and frame 2, when we say it is an inertial frame, usually our earth is taken as an inertial frame. Earth, the space surrounding the earth, whatever experiments we are conducting, like Galileo has conducted the experiments here, earth is taken approximately as inertial frame. If these are present, they are called as inertial frames. Inertia means what? There is no change. Something is inertia. Inertia means there is no change. Meaning in English it is no change. No change means invariance. Please try to understand this, from where inertia has come. Here also, no change. Inertial means invariant. If the space is invariant, that means translational invariant and rotational invariant. Even though coordinate systems are different, the frames are different. When two frames are inertial frames, that means homogeneous space and also isotropic space they are in, then if something is in the rectilinear motion in one frame, one inertial frame, the same will be applicable in the other inertial frame. If I say Newton's first law of motion, that is valid in inertial frame 1. A body will be continuously in a uniform motion until and unless it is subjected to an external force. First law and second law combined together, Newton's law, we say F dash is equal to ma. If Newton's first law and second law, they are valid in inertial frame 1, they are also valid in inertial frame 2. But if we go to an inertial frame where this particular invariance is not applicable, then Newton laws are also not applicable there. Like on earth, Newton laws are applicable because earth itself is treated as an inertial frame. Whole is treated as an inertial frame. Why I have given this introduction? These are all, whatever the laws of nature are there, what Galileo has framed and what with differentiation Newton has found out. All these nature's laws, whatever are applicable in frame 1, inertial frame, in another inertial frame also they are applicable. You cannot say that if something is an inertial frame 2, the Newton's laws are not applicable. Until and unless the frame 1 is different from the frame 2 and frame 2 is non-inertial frame. That is advanced study of physics, which we will not discuss further in this class. If you understood what is the homogeneous space, isotropic space meaning, and what is the rotational body properties, and how it is relevant to the laws of motion, and what is an inertial frame, what is the meaning of inertia, from which Newton's first law, second law and third law they are formed, and the meanings of them I will be discussing as we move forward. With this introduction, I want to close this class because class is becoming lengthy. I want to discuss further, but with one note I want to close. For all practical purposes, earth is an inertial frame. For all practical purposes, earth is equal to treated as inertial frame. It is an approximation. We will not dwell into the other side of the physics, where inertial frame of earth is also debatable. We will not go to there. We will restrict ourselves to the study of homogeneous space, isotropic space and inertial frames. Now, as far as our JEE Advanced, JEE Mains and NEET Physics is concerned, let's not dwell into other side. In an inertial frame, a particle can be identified by two things. One is its position and second is velocity. Velocity is nothing but rate of change of displacement with respect to time. In our system, in space, 3 dimensions are there, whereas time is unidimensional. Time always moves forward. Time is unidimensional. Please remember this. Moves forward. Unidimensional. Whereas space is 3-dimensional. Please remember this. That means if you have space coordinates x, y, z and time, a function is like this. If you get these 4 values, then you can find the position of that particle. This time can be related to position x, y, z because it's a coordinate system. On the basis of the degree of freedom, I have already spoken to you. And time is related to velocity, that is ds by dt. This is the final meaning of our physics. Particle function. A particle function or position can be understood by knowing its coordinates. By knowing its coordinates, we cannot easily cannot say until and unless he knows the time. Yes, at this particular point of time it is there. In the next nanosecond or microsecond, the position may vary. Hence, we should know the rate of change of position also. These 4 things we should know. How many things? X coordinate, y coordinate, z coordinate. These are all space coordinates and time coordinate. At what time? This is time. Or we can say rate of change of displacement with time. ds by dt. Velocity. When you know these things only, we will be able to understand the particle position. When we have understood the particle position, I will finally draw one diagram and leave it to you. In the next class, I will be doing it. A particle is there making a rotational motion. A particle is there making a rotational motion. That particle is on the rigid body. Rigid body has got many particles. We are studying one particle which is making a rotational motion. Px, yz. And this particle x1, y1, z1 because it's a particle. Position is known. The position vector of the particle is, I have a reference frame that is with inertial reference frame. In that I have an origin as 0, 0, 0. Then OP is my positional vector. And this positional vector with time changes its position. It may go to, after some time, to a, this is position P1, OP1, let me say. This is position P2, OP2. This is positional vector of point P, this is point P1. This is positional vector of point P2. And the positional vector of point P1, positional vector of point P2 and velocity, they are not directly depend upon the linear motion. Linear motion is a single variable dx by dt. But in a rotational motion, we have, like in z plane, we have the coordinates x and y. In this also we have the coordinates x and y. Z in the space coordinate. This is z. When we remove these red lines, you will understand better. This is z. Points are there, P1 and P2. Then here, not only the linear dimensions are changing, displacements are changing. Here, velocity is like this, tangential to the curve. Here, velocity is like this. This is V1, this is V2. There is a angular motion also. That means angle is changing. Here angle is theta 1. Here angle is theta 2 with time. And the velocity of this particle, because ultimately for studying in mechanics we require position and velocity, which we have already understood. To understand the velocity of this particle, we can be understood by understanding the rate of change of R. This is, let me say, R1, this is R2. Rate of change of R, that radial distance, and also rate of change of angle theta, because both are changing. What is delta theta here? This is delta theta. R1 minus R2 is delta R. Rate of change of R and rate of change of theta, both are required. And a vector requires a unit vector in both the directions. We have to find out the unit vector of R, and also we have to find out the unit vector of theta. That is theta. That means unit vector of R and unit vector of theta. And once we know the rate of change of theta, that should be a differentiation of unit vector also. So that it's a complicated differentiation, and the final equation will be velocity of the particle is equal to Vr plus V theta. This is because of the translation. Point P1 is moving from position to another position P2. That is a translation. This is because of the translation. This is because of the rotation. That means net velocity is equal to linear velocity or translational velocity plus rotational. Linear or translational and rotational. When you know these velocities, you will be able to understand the net velocity. And the final equation will be V bar is equal to net velocity is equal to dr by dt. That is on the basis of the displacement multiplied by unit vector r plus r into d theta by dt multiplied by unit vector theta. This is what is the meaning of what you call equation of motion in case of rigid body rotation around a particular axis. The equation derivation we will be doing it in the next class. It's very important to understand the derivation of it. Its derivation I will do it in the next class. Then not only with this, we have to understand what is A in the similar type. And we will do the derivation of velocity in the rotation of rigid body and also acceleration. When we have velocity and acceleration, we can apply our regular Newton's laws and we can find out the forces and we can resolve the forces. That's all. That is the rigid body rotation. But however, to apply these laws, there is a concept called as moment of inertia, which will also be explained in due course of time. It's a lengthy topic. It takes time. It may take more days to complete and very important. Very important. Once we understand the velocity, acceleration and Coriolis effect and what will be the effects of this velocity in different rotations, velocities in different shapes like circular motion, elliptical motion, Coriolis effect, and then we will go into the acceleration, then we will see, then we will go into the forces like central forces, net forces. It's a very big topic. Now after this we will go to gravitational force. A simple form of, after studying the effects on this, we will move to gravitational. From gravitational we move back to our classical mechanics, Newtonian mechanics. Rather we do not call it as a classical mechanics. The law in the mechanics we will go back to Newtonian mechanics because Newton is the father of mechanics. We are moving from backwards to, we are studying the toughest topic now and moving towards the lighter topics afterwards, so that you will understand better. Best of luck to everybody. If there is any value addition to your knowledge because of this lecture, please subscribe to my channel Maths and Science by IITian. Subscribe and share. Let everybody get the knowledge of this. And when you subscribe and give me motivation, I will be more motivated to give this type of lectures and give this type of information to you, so that you will understand the toughest subject also with much ease. Nothing is tough. It is only we have to remove that mind set that something is tough. I will definitely see that everything is deliberated in the same way and it is a theory subject. Please have patience. Don't jump to the problems just like that. by solving 1000 problems also, if you don't have concepts, then it will be of not much use. Let's have the concepts clear and then we solve the problems. After studying this velocity and acceleration problems, acceleration equations, derivations, after the next class, definitely we will move into some few problems on it, even at the JEE Advanced level, JEE Mains level or NEET Physics level. Best of luck. Thank you for listening to me. Thank you for spending this much time to view my lecture. Thank you.